Before proceeding with any service on your machine, please read and understand the safety sections of the Instructions and Parts List Manual. All operations should be performed by qualified personnel. The recommended preventative maintenance schedule can be found in your Instructions and Parts List Manual, so please refer to it for maintaining your 3M Pneumatic equipment. Many of the adjustments for your case sealer can be found in the Maintenance and Repair section of the Instructions and Parts List Manual. For 3M AccuGlide taping head repair and adjustments, refer to Manual 2, also included in the Instructions and Parts List Manual. Turn off your case sealer before performing any maintenance or inspections and make sure to unplug the power cord. All the default settings can be found in Manual 2 of your Instructions and Parts List Manual. The tension roller is used to provide the proper amount of tension on the tape for application and cutting. Having an incorrect tension setting can lead to short or long tape leg lengths or cutting problems. Turn the nut clockwise to increase the tension and counterclockwise to decrease the tape tension. The tension setting is identified by means of the numbered label. The drum's tension setting is used to provide the proper amount of force to prevent overcoasting of the tape supply roll and uses a tape drum handle to lock and unlock the tape supply roll to the drum. Turn the nut clockwise to increase tension and counterclockwise to decrease the tape supply tension. The tension setting is identified by means of the numbered label. Be aware the blade is very sharp, so always use caution when servicing. Inspect that the cutting blade is secured and there are no broken or damaged teeth, and replace if necessary. Adhesive buildup of fragments of tape that stick to the cutting blade will cause tape cutting problems. Grease will aid in preventing these issues, so apply to the pad located on the underside of the blade guard. Note that there are wipers positioned in the middle and at the end of the taping head. Wipers assist in adhering tape to the box, so replace when worn. The springs have end hooks that pivot about the spring posts, so lubricating the posts with grease will extend the life of the main and cutoff springs. Both the buffing and applying rollers are important for applying and adhering the tape to the box, so inspect for signs of wear, cuts, or cracks and replace as necessary. There are bumpers for the tape apply and cutoff mechanisms. Bumpers affect mechanism performance, so replace when worn or damaged. This picture depicts the complete thread-up of the 3M AccuGlide 4 taping head with the optional dancer arm roller. If the optional dancer roller is not required, thread the tape from the supply roll directly to the tension wrap roller. Note that the distinguishing feature between the lower and upper taping heads are the main spring only. The red marked spring is the stronger of the two and is used for the lower head. The spring with no marking is the weaker and used on the upper taping head. There are 4 retroreflector photo eye sensors on the machine bed frame used to control the complete taping cycle. Older models had 5 photo eye sensors, which included a case-present photo eye. The case centering photo eye is closest to the infeed end of the machine and is used to detect the case for centering. The lower taping head blade retract photo eye is used to retract the blade cutting mechanism when a case is detected and is closest to the lower head. Retraction removes pressure from the bottom side of the box during the taping cycle to prevent it from collapsing. The cutting mechanism is re-enabled to cut the tape after the majority of the tape is applied. The upper taping head blade retract photo eye performs the same function as previously described with the lower retract except for the top of the box. The photo eye sensor closest to the outfeed bed of the machine is used to determine tape cycle complete and when a new box can enter the machine. Note that the sensor will exhibit a green color when not blocked and an orange color when blocked. Remove the screws securing the regulator cover. The regulator on the right is used to set the upper assembly counterbalance force. The regulator on the left is used for controlling the force applied by the centering guides. Both are preset at the factory. The counterbalance gauge should indicate 38 to 40 psi as set from the factory. If not enough counterbalance pressure is used, the upper assembly can crush the box being taped, and with too much, the belts can slip, causing difficulty moving the box through the machine. If adjustment of the counterbalance pressure is required, first unlock the regulator by pulling out the dial. Rotate clockwise to increase pressure or counterclockwise to lower it. Push the dial back in to lock the regulator setting. The box centering guide regulator should be adjusted to provide sufficient force to aid in centering your heaviest box. Check your instructions and parts list manual for factory settings. Rotate the upward cover into position and reinstall the retaining screws. Turn the main air valve to the on position. Note the air pressure gauge should read 100 psig. If not, adjust the air regulator so the gauge reads 100 psig and lock into position. The centering guide should close inward to a minimum width of 7 inches and outward to a maximum width of 26 inches. Throughput efficiency can be increased by limiting the maximum travel of the centering arms to the largest case width the machine will run. To improve centering efficiency, use the box width centering adjustment knob. Turning the knob clockwise adjusts the guides to open up less than their maximum width of 26 inches, and counterclockwise increases the maximum width up to 26 inches. Check to make sure the drive belts and orange friction rings are clean and not worn. Replace as necessary. If replacement is necessary, remove the guards. Belt tension can be obtained by tightening the adjustment screw so that a moderate pulling force of 3.5 kilograms or 7 pounds applied at the midspan will deflect the belt 25 millimeters or 1 inch. The upper assembly raises by depressing the red actuator switch. The movement is detected by a proximity sensor under the cover. The PLC controller senses the on condition of the proximity sensor and energizes the solenoid valve that provides air pressure to the air column cylinders, raising the upper assembly. Check to ensure the upper assembly raises and lowers smoothly, and note the red actuator will wear over time and will need to be replaced for proper operation. Check to ensure both latches lock the upper assembly in the raised position. Sequence the reset, start, stop, and emergency stop push buttons to test they are working properly, noting that the blue light illuminates when the machine has been reset. If necessary, replace any non-functioning or visually damaged components. Next, check the operation of your machine by sealing boxes. Restart. Both yellow column lights should be illuminated. When pushing the box into the machine, position your hands near the back of the box. Then push the box to depress the red actuator to raise the upper assembly above the box. Move the box into the case sealer to a point so the upper belts engage the top of the box as the upper assembly lowers. Always remember to keep your hands clear of moving parts. During normal use, the machine surfaces will build up with contaminants like corrugated dust, so it's important to periodically clean those surfaces. With the upper assembly locked in the upper position, first shut off the machine and unplug the power cord from the power outlet. Use a mildly damp rag to wipe the machine bottom frame, bed plates, and contaminants on all the belts. It's important to clean underneath the belts as well because dust can collect in the orange slip rings, causing the belts to slip or track off during operation. A vacuum cleaner can assist during this operation, but never use compressed air to blow the dust as this can be hazardous. Remove the lower taping head and clean it along with the cavity using the rag and vacuum as necessary. Repeat this procedure on the upper assembly, noting that it can be easier to lower it first by repowering the machine. If so, be sure to remove power from the machine before cleaning the upper assembly. With the upper assembly locked in the upper position, first shut off the machine and unplug the power cord from the power outlet. Following the recommended preventive maintenance schedule, remove the guard cover plate to access the chain and sprocket. If necessary, clean the chain and sprocket and then apply a general purpose grease. With hands clear of the chain and sprocket, manually rotate by pushing on the belt to expose other surfaces to grease. When complete, be sure to reattach the guard cover plate using the retained fasteners after greasing. Perform a similar procedure for the lower drive system by first removing the taping head, then the guard belt plate. Be sure to reattach the guard cover plate using the retaining fasteners after greasing. Reinstall the lower taping head. With the upper assembly in the lower position, shut off the machine and unplug the power cord from the power outlet. Following the recommended preventive maintenance schedule, remove the fasteners that attach the column guard belts to the upper assembly. Carefully slide the belt upward and around the back side of the column, exposing the bearing block and rail. Clean off any corrugated dust or other contaminants on the bearing blocks and rails. Then grease the Zerk fitting of the bearing block and lightly coat the outside of the rail for each column. Be sure to reattach the column guard belts using the previously removed fasteners. Inspect the operation of the box centering guides by inserting both light and heavyweight boxes used in the application. The rails should apply just enough force to aid in centering the heaviest box, but not too much, making it difficult to feed the lightest box into the machine. Cycle the upper assembly by pressing the red nose switch, noting the upper assembly should be responsive, smoothly moving up and down. Adjust the regulator as required as shown earlier in this video. The complete electrical schematic can be found in your instructions and parts list owner's manual for your machine. The push button station, mounted on the side of your machine, has buttons for resetting, starting, and stopping. First press the reset push button after a power-up. An emergency stop, or fault condition, to reset the machine, noting a blue light illuminates. Pressing the white button starts the machine, and pressing the black button stops the machine. The emergency stop push button is located on top of the upper assembly. Depress to emergency stop the machine. Twist to unlock the e-stop before resetting the machine. The electrical enclosure contains hazardous voltages, so be sure to unplug the power cord before servicing. Refer to the instructions and parts list owner's manual for the electrical schematic diagrams. The circuit breaker is located in the upper right corner, and in situations of excessive current overload will trip and remove power from the machine. The correct amperage setting can be found in your instructions and parts list manual. After clearing the overload condition, the breaker is reset by rotating the handle. The fuses are located to the left of the circuit breaker. To replace a fuse, simply grasp and pivot the fuse block downward to expose and remove the defective fuse. Insert the new fuse, then pivot upward until the fuse block locks into place. The transformer converts the main line 120 AC volts to 24 AC volts required by the DC power supply. The DC power supply converts the 24 AC voltage to 24 volts DC voltage needed to power up the PLC, sensors, solenoids, lights, and control relays. There are 3 relays. One functions as a master control relay for removing power in the event of an e-stop and reapplying power once the e-stop is cleared and a reset is performed. A second relay acts as a motor contactor, applying AC power to the drive motors via the PLC. The third relay senses the low pressure switch and signals the PLC the pressure status. The PLC and an additional I/O module is located in the upper left corner of the electrical control panel, and it controls the machine operation. The toggle switch can be cycled on and off to set the desired function of the tape application monitoring. Please refer to the instructions and parts list owner's manual for the pneumatic schematic. Before you can use your machine, you will need to attach the proper air connection. Be sure the fitting or air fitting hose assembly is large enough to provide the necessary airflow, as specified in your instructions and parts list owner's manual. The air valves are located on the inner machine frame, and access is obtained by removal of the bed covers. The double-acting air cylinder housed in the centering section, mounted to the infeed of the machine, drives a serpentine chain and gear system that pivots the rails inward to center the box so tape will be applied on the major flap seam. The retroreflective sensor detects the presence of a box and signals the PLC to energize the solenoid valve to close or open the rails. Both the lower and upper taping heads have an air cylinder enclosed that allows the blade cutoff mechanism to retract. Retracting the mechanism removes excess bottom and top forces in order to help prevent an underfilled box from collapsing. During the early portion of the taping cycle, the blade cutoff is retracted by the air cylinder and extended just before the tape needs to be cut and buffed. Each head has a corresponding retroreflective sensor on the bed that detects the position of the box and signals the PLC to enable or disable the blade cutoff mechanism for this operation. The low pressure switch closes the pressures at or above the predetermined value and opens up for lower pressures. If the pressure is too low, the PLC will be signaled and a fault will occur. Lifting and rotating clockwise increases the minimum pressure required for machine operation. Rotating counterclockwise decreases the required pressure. Once set, push downward to lock into position. Refer to your instructions and parts list owner's manual for the recommended setting. This procedure outlines setting the required tape application monitor state, whereby the TAM can be completely disabled, both heads are enabled for monitoring, or either the upper or bottom tape head is enabled only. The toggle switch is found in the electrical panel. Each taping head has two sensors positioned on a bracket that is mounted to the case sealer. The lowest sensor on the bracket sends and receives a beam of light that strikes a patterned surface on the back side of the tension roller. During normal operation, tape is applied to the box and the tension roller rotates while the sensor is detecting the on-off signals of light from the reflective and non-reflective pattern. Whether tape is properly applied or cut is determined by box position and the on-off signals of light received by the sensor. For proper operation, ensure that the reflective pattern on the tension roller is clean and not damaged, and the beam of light is pointing in the middle of the reflective surface. Adjust the sensor in the slot as necessary. The sensor mounted on the upper position of the bracket is used for sensing low tape and works similar to the sensor just described. Light from the sensor is reflected back if the supply roll has an adequate amount. A low tape condition is created when the sensor no longer detects the supply roll edge. Adjust the sensor in the slot to set the low tape condition. For machines with the tape application monitor option, the beacon light displays color codes to help identify the source of the tape fault. Green for normal operation, purple for a lower tape fault, red for an upper tape fault, blue to indicate boxes were spaced too close, and yellow indicates a low tape condition.